negative comes out phi, and we get 4 pi, and put this negative over that right hand side, and we get Laplacian of phi equals to minus 4 pi rho. Laplacian of phi equals to minus 4 pi rho. This is called the Poisson's equation. It's called the Poisson's equation. Or if you can even, well, this is the case when there is some charge density. Suppose there is a region in which there is no charge density. Then in that case, it will satisfy this equation. This is called the Laplace equation. The Laplace equation and the Poisson's equation. These are the two equations. So these equations will be our next concern. But how to solve these equations? What is it? Well, how to solve these conditions? How to solve these, and under what conditions are these equations solvable? What information do we need to put in them so that we will get our solution? And these things are called boundary value problems. And so the boundary value problems are similar to if you have taken a course on, say, ordinary differential equations. You know what is meant by an initial value problem. So you give an initial value at particular points and you get the solution. As a second order differential equation, then you put the initial values, you put one value of x and x prime at 0, and you get the solution. But here you have to stay here. The matter is different. You have different kind of boundary conditions. Well, we'll talk about them. We'll talk about them soon. They are called Dirichlet boundary conditions, Newman boundary conditions, or the mixed or the Robin boundary conditions. Okay, so we'll talk about them and the techniques to solve them. Before actually solving them, we will formally solve them, we will symbolically solve them in the form of an integral equation. So these are basically differential equations of the second order, partial differential equations, as you can see. So this one is not. This one is an. I think this one is an elliptical equation. If I'm not wrong, there are some types of differential equations. There are some types of differential equations like hyperbolic, elliptic, and things like that. If you take in a course on partial differential equations, so it's very interesting. We will talk about those things. So here's what we have got, and this is in fact the Maxwell's equations for electrostatics. These equations are Maxwell's equations for electrostatics. This is all what you can do with electrostatics. If you got these equations, you can do everything with electrostatics. So that's the thing. So that's the essence of today. And yeah. So actually, I do not want to start solving those boundary conditions and things like that. These are not in Stringer's book. I mean, in the Stringer's book is in different order. In the Stringer's book, you will find it's a discussion of boundary conditions, solving boundary value problems in the end of the book, in the last chapters, and in Jackson's book, you will find it in the first few chapters of the book. So we intend to cover these boundary value problems, as it may seem very interesting to you. It may seem interesting to me, and I mean, it is an interesting field, and it should not be postponed. So we'll study those things just in the next lecture, and I will take the help of Jackson, and let's see if we can cover a few research papers as well, like reading a research paper. Okay. So let's see, and if you like, if you have spotted any mistake or anything in here, or I have said anything wrong, then please point me out in the comments. I would love if anyone would correct me, and thank you. That's all from my side today, and see you again in lecture number 4.